Hey guys, how's everything going? This is JSer who is not good at algorithms. In this video, I'm going to take a look at 398, a random pick index. We're given an array of integers with possible duplicates. It is not sorted. Randomly output the index of a given target number. We can assume that the given target number must exist. Okay. The array size can be very large. Solution that uses too much extra space will not pass the judge. Like this. We need if we call pick 3, we need to return either 2, 3, or 4 randomly. Well, because the integers are not sorted and they may be disjoint, right? Like 3, they might be 3, 3, 4, and then 3. Well, the naive solution would be keep index map, right? So const index map for net num of let I we loop through the nums, and if index map has nums I, if it's not there, we set it to empty array, right? Yeah, and then we get nums I. We push the index in to the map. So the map actually will become a map of index num index 1, index 2, something like this. So when we pick, first we get indexes equals this. Okay, bad this index map and get a target, and then the const random index equals it should be something like this, right? And then we just return indices random I. It should be right. I'm so sorry. Let's try. Cool. Let's submit. We are accepted, but very slow. Very, very slow. It's maybe because we're using too much space. So for this case, not that bad. Let's try to analyze our solution with first. This is actually this is just a constant here. So the problem becomes here. We use a map. Actually, for the word, we actually will keep the index for all, right? Keep number and yeah. So actually, we cost linear here for space. And here, when we traversed, the time actually for the solution constructor, it's a linear time. O n and the big O n. For pick, it's constant. So, is there any better solution? I'm not sure. Let's try to look at the discuss. Yeah, map, right? Fisher Yachts Shuffle. What is this? Reservoir sampling. What? JavaScript constant space and single one linear time solution. Wow. Nums length, pick. If this length is 0, return 0. Okay. Set count 0, and then when we pick something, we will loop through. Ugh. What is this? What is this? It says when we are looping through the numbers, and we actually max random. I'm getting the count, get the previous one, then count it, and while we're looping through it, and we get a random index. If it's 0, we return we set the result to the I. Ah, I see. So actually, this is an idea that suppose there are 3. Suppose there are 3 indexes when we're looping through the first one, and the second one, and the third one. So for each length, like for the index of for the length of 1, if we pick one, or there are 2, we pick one, or the 3, we pick one. It should be actually, yes. Wow, this is clever. So I'll come in here. It says for if we like 3 index, the first one is I1, I2, and I3, right? When we meet the I1, we run this math random if it equals to 1, 0. It means if it falls into I1. Why, right? Of course, it's because it's only 1, so it must be returned 1 possibility. But for I2, if we run into because now we get 2 numbers, right? So now the possibility, the previous one actually is released. There's the possibility was 1, and the possibility here for each was 0.5, 0.5. Now I have 1, 2, I 3. We run it. So first one, second one. So it's 3, 1 over 3, 1 of 3, 1 of 3. Why we will set the result every time we check? Because we don't know how many numbers are there, right? So we check every time. If we know the length beforehand, we could just run the last time for the last time, but we don't know how many numbers are there. This is the problem. So we will just run it, and we don't even know the previous one, right? We don't know the previous number or the last number, previous index, or the rest second index or the third index. So we just run it again and over and again every time we get the target. So how would the possibility be distributed here? For first index, ah, you see, because for the first index, it's actually out of 3 rounds, right? The first index we round, so suppose there are n index and I1 is 1, so actually it's 1 times 1 out of 10 n rounds, right? And if there are 2, so it's 2 0.2 out of 1 out of 2 times how many, this is another, how many, how many, this one, so there's be n index, yeah, this would be 2 and 2. Wait a minute. What's the possibility? Am I getting this right? So for 3 index, we will pick 3 times. For the first time, it must be itself. Okay, we set it to 1. And the second time, it will be a possibility of half of the chance, right? And this be used to remove the result here. So the check here is if the math random is the previous one. If it is I1, we set it to I2. But this actually means if it is one of the chance of this means n minus 1, right? Okay, so oh yeah, so this actually is n minus 1 out of n. So for I1, it will be I times out of 1. Yeah, so it's 1. And then for 2, okay, so there will be 1 out of 2 the chance we set it I2, right? You see, so I1 is of course 2, so I1 is also 1 out of 2. When there are 3, you see there was 1 of 3, we set it to I3, right? But for the rest, for the 3, for the 2 out of 3 chance that we don't touch, it will fall onto the previous one, which means it's half of the chance, right? So it's 1 I1, I2. Wow, this is clever. So I got this idea. Is that for I1, I2, I3 until IN, to random pick one number, we could actually pick I1 for the chance of 1 out of 1. Pick I2 for chance of 1 out of 2. Pick I3 for chance out of 1 out of 3. Pick IN for chance of 1 out of n. Well, this chance for IN is right, so the previous one is we will have the chance of n minus 1 out of n, as we analyze here, right? It was picked before. Yeah. Wow, this is clever. Learn something cool. This is very cool. I'd like to click upload. Is there any theory for this one? So if we think another way, is that suppose there's n minus 1, I minus 1, we already picked the number, we already set 1, now we have an n minus, a new number. So what we care is that what we only care is that if IN is not in the final result, it's already picked randomly, right? If you want to add IN in, it must be n 1 out of n chance. So we only care for that chance to update the result to IN. For the other ones, it will be already done in the previous loops. Wow, clever, man. This yes, of course, the time and space complex time would be the construction will be very nothing, but the pick will actually, for worst case, will be in linear time for time, right? Or for space, it's constant, I think. Wow, this is very cool. For our solution, actually, we're using both linear time and space. Yeah, okay, so that's all for this problem. See you next time. Bye bye.